I was at a ML startup, and I used TensorFlow for that startup for the internship, and I was like blown away. I was like, wow, I didn't realize you could do so many things with it. So I went to like a couple of my professors and was like, can you teach a course on it? And my professor was like, I don't have time. Like, why don't you teach it? So I was like, okay.
You're listening to Gradient Descent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Bewald. Chip is a machine learning expert that currently works at a startup focusing on machine learning production pipelines. Prior to that, she worked at NVIDIA, Netflix, and Primer. She also taught the course at Stanford on TensorFlow for deep learning research. And maybe most fascinatingly, before she became a machine learning expert, she was a best-selling author in Vietnam. I'm super excited to talk to her. My first question for you when I was thinking about interviewing you was actually, I really want to hear the whole story about how you got into machine learning. Like I kind of have bits and pieces of your background that you've told me in the past, but like, tell me your life story.
Okay.
I guess I don't usually ask that, but I really want to hear it.
How much time do we have? Like, do you want a full version?
We can cut you down, but like, but how did you get into tech in the first place? I guess.
So it's a funny story because I come from a very non-tech background, like as fuzzy as you can think of. So after high school, I didn't go to college and I started traveling. You know, like it's a full picture. You think of hippie, like that was me. So I did that for 3 years, and in the process, I was writing. I was writing for newspaper. I hosted a couple of columns, and I wrote a couple of books, which got me into more troubles than I wanted, that I wished for.
Wait,
And
really? It got you into trouble?
yeah,
Why?
so like internet popularity is like a double-edged sword. So my books got very popular, and okay, so say very popular sounds arrogant. It's like more popular than
they were bestsellers, right? I think it's fair to say that they were very popular. What were the books about?
In Vietnam. So it's about traveling, like the people I met on the road, and I was young. I didn't know how to handle all the attention, and people were like, "Oh, it's impossible that a girl can't possibly travel by herself." And they were like, "Oh, she didn't write the book. She didn't write any of that. Like, she had people like running things for her, doing things for her. Like, people accused her of having a lot of money to be able to travel at all." So there was a lot of controversies, and I was a little bit like offended. It was like, who are these people? Why is it like making me answer on these stupid questions? But at that time, I did not know how to handle that, and it caused a lot of like a backlash. So I was like, okay, I'm so tired of this. I'm going back to school. So I went back to Stanford, and I was thinking of doing something like writing, like direct writing, or like political science. But then, I was at Stanford, and people told me that the question is not whether you should take a CS course or when you're gonna do it, because 90% of like Stanford undergrad take a CS course at some point. So I just took a course in my first quarter, and I really liked it.
In your first quarter there?
Mm-hmm.
Wow.
Like, it's an introductory course.
You came to Stanford. How old were you? You had already been a best-selling author?
Ask that question. So I was like older than my classmates. And so I took my first quarter. It was fun. And I kept on doing more courses. And before I knew it, I was a CS major. And I took an AI course. I cried a lot in the first class. It was so difficult. But it was so very flashy. I think I came to Stanford at the time. Like, it was the peak of the AI hype. Am I allowed to say AI hype here, or
sure,
it's like too touchy? Yeah. Okay.
You can say literally whatever you want.
Okay. So I did that, and it was fun. And yeah, here I am. And I think in my third year, I taught a course. I created and taught a course.
Your third year as an undergrad?
Yeah.
Wow, I try to think about what I was doing as an undergrad, and I feel embarrassed.
Okay, to be fair, I was like older than people, right? I also didn't have to spend time on like frat parties, like impress people. I was pretty much done with the party scene by then.
Right. And so you taught a really popular class, right? I think you could say it was a popular class. I could say.
I think people can say that. I feel like it was unexpected. Like I didn't even know that the course was popular. I was just like ditching it. And one day I walked into a dining hall and a friend was like, "Did you see my comment about you on Hacker News?" And I was like, "Why would anyone say anything about me on Hacker News?" And it turned out that my course was on the front page of like Hacker News. And I was like, "Wow, it's interesting." And at some point, it yeah, I didn't know what happened. I was not like really active on Twitter back then. And it's just one day, just open Twitter file, having 10,000 followers. And I'm like, wow, who are these people? It was great.
Well, it's a timely class. Like, what was the topic of
Hmm.
the class? Just for people might not know.
Oh, it was TensorFlow. I think it was at the right time. Like TensorFlow was very popular back in 2016. Wow, it's crazy how fast things change. Like back then, 2016, like TensorFlow was all what people talk about, and now like it's all what people complain about. So yeah. So I taught a course on TensorFlow. I think the official name is TensorFlow for Deep Learning Research, which is also a very flashy name. And so I think I put a lot like all the materials online, and I think it was maybe the first college level course on TensorFlow.
Uh-huh.
And
And
also like
2016,
the
I'm trying to remember it. Like, I think you had to compile it yourself, right, to get it to use the GPU back then. I'm trying to remember. I remember just installing TensorFlow was a pretty painful experience for me.
it was not. I don't remember it to be so painful. It was just some concept was a little bit hard to
Mm.
grasp, as in like a computation graph. So
Hmm.
you have to like build a graph first before you can run it. So I think with TensorFlow 2.0 right now is a bit different.
Uh-huh.
Yeah.
Got it. And so, I mean, how did you come up with the material for that class? Like, how did you even think of like what to?
So when I started teaching the course, I was just hoping to learn. As you know, I was like, so I started thinking about the course in like sophomore summer, like second year. So I didn't know a lot. I was at as a ML startup, and I used TensorFlow for that startup for the internship, and I was like blown away. I was like, wow, I didn't realize you could do so many things with it. So I went to like a couple of my professors and was like, can you teach a course on it? And my professor was like, I don't have time. Like, why don't you teach it? So
Mm.
so I was like, okay. And I got a lot of people to help me. So I have some friends at Google who know a lot about TensorFlow. I have professors who like overlook, like take a look, like who look at my curriculum and I'll just give a lot of feedback. I read lecture notes. I was really nervous, so I had so I had really good friends who was coerced into being my fake students. So if I every like lecture, I would make them sit and listen to me give them like a fake lecture.
Really?
It was yeah.
Uh-huh.
Yeah, so I think I got a lot of help. So it was like learning together with my students. I didn't think of it as teaching as much as like group study.
That's super cool. Did you when you uh came to Stanford, you hadn't taken any computer science class before?
So I came from a math background, so I did math in high school.
Uh-huh.
So I think I think like we also took some CS courses, but you know
Oh
like it's
yeah.
like more like very basic. I don't remember, it was like blue screen back then. Wow. Yeah.
It just seems
We
really
are.
amazing. Like, you
Mhm.
went from introductory to computer science type stuff to teaching a computer science, teaching a TensorFlow class like 2 years later is like amazing. Do you have any thought, like any advice to other people that want to learn this stuff?
I think it's one of the beauty of computer science is just the entry barrier is really low. So also ML, and also especially with the experiment oriented progress that you actually like don't need to know a lot of theories to make a
Mhm.
contribution. So I've seen people who get into ML for like a year and is able to make a like pretty great project. Which I mean, I'm still like ambivalent about it. Like, it's good as it like lowers the entry barrier, which means like allows more people from different backgrounds to join. But also like, what is say about field when like somebody who like joined for a year like can make a pretty mind blowing experiment. So I don't know. I
Oh,
don't know. I
I
don't
mean,
know
maybe it
how
means
to
there's
feel
lots
about
of interesting stuff to try.
it. So yeah, I don't know any advice. I'm also skeptical of giving advice. I think it's just like get your hands dirty, like try things out, and befriend smart people. I think that's a.
Befriend smart people.
I have friends smarter than you. I don't think I can have got anything done without my friends. Really, yeah.
Oh, that's so cool. Um,
Mm.
I think that's good advice. Why did you choose to go into AI?
For me, it was just a promise that AI, as I say, I held. So I come from a village in Vietnam, and I traveled, and over the time, I realized that language barriers can actually like it could be great if you can like overcome the language barrier. For example, like the majority of human knowledge online actually written in English, and people who don't speak English like can't really access that. Like people in my hometown like can't really read anything that I write in English, or my parents are afraid of like visiting me in the US because they wouldn't be sure how to navigate the airport or how to get here. So I think so at this time I was very interested in machine translation.
Hmm.
So I'm thinking, yeah, like if you can automate, like an automate the translation in process, then it could be really really helpful. Then if we can overcome the language barriers and help people from maybe my village can access human knowledge or just to step out of the border.
That's so cool.
That's what I thought back then. A very idealistic, yeah.
What are the topics that are most interesting to you right now in machine learning?
So I think over time I think what we are lacking is better engineering in machine learning. So people are so there are two aspects, both as in engineering in research and engineering in production.
Hmm.
So in research, there are a lot of researchers who are amazing at what they do, but who also like are not great engineers. And it's not because like of them. It's just because human like our time is limited. If you focus too much on research, we can't expect them to be like great engineers. So I wonder if there's a better is we can build a good tool set to help researchers carry out the research more efficiently and have like more. And also if you have clean code, it's easier to control experiments and like help with reproducibility. And in productions, I also think that there are people. Also, the gap between researchers and production engineers. I think there have been a lot of progresses in research in machine learning, and now it's just a question like how do we bring the research into productions, and that's what I'm very interested in. And also startups that I'm part of right now is also focusing on that by helping companies productionize machine learning research.
Cool.
Hi, we'd love to take a moment to tell you guys about Weights and Biases. Weights and Biases is a tool that helps you track and visualize every detail of your machine learning models. We help you debug your machine learning models in real time, collaborate easily, and advance the state of the art in machine learning. You can integrate weights and biases into your models with just a few lines of code. With hyperparameter sweeps, you can find the best set of hyperparameters for your models automatically. You can also track and compare how many GPU resources your models are using. With one line of code, you can visualize model predictions in form of images, videos, audio, plotly charts, molecular data, segmentation maps, and 3D point clouds. You can save everything you need to reproduce your models days, weeks, or even months after training. Finally, with reports, you can make your models come alive. Reports are like blog posts in which your readers can interact with your model metrics and predictions. Reports serve as a centralized repository of metrics, predictions, hyperparameters tried, and accompanying nodes. All of this together gives you a bird's eye view of your machine learning workflow. You can use reports to share your model insights, keep your team on the same page, and collaborate effectively remotely. I'll leave a link in the show notes below to help you get started. And now, let's get back to the episode.
And you've worked at some big companies too. I guess like generally, like what kinds of problems do you see when companies try to take research and productionize it? Like, what are the main ways that you see companies fail at this?
I think one of the big thing is a lot of companies are chasing buzzword. For example, when
Chasing
bird came out,
buzzwords.
yes.
I
So
see.
everyone's like, yeah, how can we use bird? How can we transform it? And you can look at them and say like, you actually don't need that. You don't even need deep learning. Like a lot of the problems can be solved by traditional classical algorithms. So sometimes like companies like, um, yeah, this is one should do use very fancy techniques. It the reason can be because they don't really understand what is happening. Because I think there are a lot of there's a lot of misunderstanding in AI reporting. Like if you see like a lot of journalists or reporters talking about AI, and if they don't have background in AI, then they might just like simplify or just doesn't exactly like reflect what exactly is going on. And the second is some companies might just want you buzzword to attract clients. Like you say like, oh, we are using state of the art techniques. Then yes, so some companies actually like go out of their way to like to try to use that. So that's one problem. I think the second is that so this is the problem with the lack of data, and I think Lucas, I think you pretty knows that very well because you work with you also try to solve the problem, right? So in research, we people work with very clean static data set, and you need the data set to be clean and static because you want to focus on developing models. But
Hmm.
in productions, you already have to usually have like I think as models are being more and more commoditized, as you can just take off the shelf model. So the bottleneck now is data, and real world data is nowhere close to like that like research data. So the problem is like collect data and verify data and how to cope with constantly distribution shifting, data drift. So
Hmm.
there's a problem with data. And so another problem is with interpretability.
Uh-huh.
So in research, like sometimes you care more about like state of the art leaderboard, but also in real world, like you sometimes you like if you've been like you just don't care about the accuracy or F1 or whatever metric you pursuing, but also care about like how can we explain the decisions that the model is
Hmm.
making. Yeah, but I think like a lot of them like people are I think a lot of topic people are like focusing a lot of time on. So I think we are making progress.
It's funny. I saw a tweet recently. I think it was someone at OpenAI who was arguing
Mhm.
that folks should not teach anything besides neural
Oh
nets
my
anymore.
god, it's such a clickbait.
And it's funny because it reminded me of when I was in when I got my first job out of school. There was sort of a similar debate, but it was like different topics. So like it was basically like machine learning versus rule based systems, and there were a
Yeah,
lot of kind of older researchers who had kind of bet their careers on like logic and rule based systems, and they would say, oh, like it's like obviously like you should do both, and I was like, ah, come on, these rule based systems don't really work on anything, and like
yeah.
can you find me like a benchmark where it actually makes sense to do a rule based system? And I was thinking that's how I felt at the time, and I think I might still. I mean, you don't see a lot of rule based systems in production in the last decade or two, um, or I don't come across them, I guess. And then I was thinking, when that person made that clickbaity tweet, I was like, no, no, that's ridiculous. But I was I was wondering, am I now like the old guy who's like trying to just justify the things that I
No,
know about?
no. Did you get baited? Do you participate in the discussion?
No, I'm like always afraid of controversial topics on Twitter. I
It's
never.
not even controversial. It's just wrong. I mean, like I don't get it. I mean, if it's not from somebody OpenAI, I would think that that person was trolling. I don't know, but I don't know. Maybe he's trolling. I'm not even sure anymore.
But it's funny because I think your work is mostly in, unlike my work, which is if you look at my own research, it's not in neural nets at all. I mean, you actually work in neural nets, so I guess what are the non deep learning algorithms that you think are useful that you would keep around, and why would you use a different one?
I mean, like like XGBoost is still like the most popular algorithm for Kaggle like competitions. So a lot of them are still very good. Like okay, nearest neighbors are still very good for anomaly detection. So a lot of like really great algorithms. Like a lot of people now they don't even know what boosting or like backing is. So which is a bit sad. So yeah, so a lot of things. I think so. It's the other day my friend was telling me about like, how he was interviewing somebody, and that person could explain it perfectly well what a transform model is, but can't explain what a decision tree is. And it was just a bit, I don't know. Maybe I'm old too. I mean, I don't even know anymore.
What are the situations where like you would recommend using like a boosted tree versus like a neural network approach?
I think definitely for baseline, for example, right? If a simple model does a job reasonably well, I mean, there's always values in trying, but if in production, the simpler the model is, actually, it's easier to understand and to implement and to avoid mistake.
I see. So like if you don't
Mhm.
get improvement from like deep, like more complicated methods, don't go there.
I mean, like it's also hard to tell because a lot of improvements incremental, right? So you can say that oh, this only give like 1% improvement. It's not worth it. But even like for that 1% improvement, if more time investing, you can like get like another and another, and over time you can get up to 10% improvement. But then if you like just like stifle it from the beginning, then you will never be able to reach the point where it should be. So I'm just saying this like it's I'm not pro like not using deep learning. I'm actually very pro deep learning. I'm just saying that to start we should not forget like simpler baselines, and I don't think we spend enough time talking about baselines or implementing baseline.
Interesting. A lot of people have said that. I happen to agree with it. But if
Mm.
someone is going to ask you why are baselines important, how would you answer that?
Because like a metric by itself doesn't mean anything, right? You say 90% accuracy doesn't mean anything. So we say, oh, my model is amazing, can like it has like this accuracy. But then like what does it even mean? And for example, like somebody showed me this model is like 90% accuracy, and I said like, wow, if it's just like predict at random, if it's like like 89% accuracy already. So what's the hope? What is the point of like getting this? So baselines are I think the baselines are landmarks to help you localize and where the model performance is and where you want to get to. So one thing very interesting in human baseline, for example, like what like if humans do on this data set, like how well it could do. So we say
Hmm.
like maybe say 90% is also like really amazing. If the human baseline is like 85%, so we say oh, this like superhuman performance.
Hmm.
But even like if the human base like 99%, then we know that we have a lot to go.
Right, 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 right,
Yeah.
right. So it's like the human baseline is kind of like maybe in some sense like a best case scenario.
Oracle.
Yeah.
Yeah. Yeah. I think it's in some cases, in a lot of cases, the humans baseline is Oracle, but it's not always. Yeah.
Right. Do you want to talk? Another thing I'm kind of curious about is your work on. I mean, just because I think like, um, fake news is probably going to be a big topic again with the election coming up.
I think it was just a fun class project. So it was after the election, and we're curious to see. So like I think echo chamber can also help like echoing like fake news, right? I feel like
Hmm.
the same fake news usually circulating in the same echo chamber. Um, and like if one echo chamber shares a certain piece of news and another echo chamber shares similar news but with different perspectives, this might be some, I'm not sure how helpful it's going to be, but it might be interesting to like cross share, like brings the piece of news from one's perspective to another echo chamber. Not fake news, of course. There's no point in like spreading fake news from one echo chamber to another. So what we did was that we got a lot of tweets and from hashtag. So at that time was after the election, so we collected a lot of tweets from during the elections in one certain state. And what we did was we have some seed hashtags that we know was like whether it's pro-Republican or pro-Democratic. So from those seed hashtags, we make assumptions that if two hashtags belong in the same tweet, then they are likely have the same sentiment, right? Like uh, so like if one hashtag appears next to a hashtag that pro Republicans, then it's likely to also be pro Republican. So from that we had an algorithm which is like just to resolve conflicts. It's very simple, like majority voting. So we will able to like label about like 1,000 hashtags.
Mhm.
And so from these hashtags, so we also make
And
some
sorry, just making
assumption.
sure I understand. So you label the hashtags as like liberal or conservative, essentially,
Yes,
based on
yes,
what they co-occurred with.
yes, yes. So after that, so we look on the tweets. So we build a graph of relationship between users. For example, if user A reply to or like retweet another user, there's a link between them. So we build graphs of users, and we also look at the kind of the hashtags they use. And so we try to predict whether a person is a liberal or conservative. And then we look at and then we use some graph algorithms to detect communities. And then we look at the communities and see like whether this community is have much more conservatives than liberal. And it was really fascinating because we found as at like about 50% of the communities we found are like neutral. There's like there's a difference between the number of conservative or liberals. It's not that high, but then about 25% of them are like conservative. For example, like the number of conservative members are like more than 3 times higher than like Democrat, and there's 25% Democrat. Community.
So you found the echo chambers.
So we
And then-
found it's like I'm not sure if it's an echo chamber, but it's definitely like people who share similar beliefs definitely have stronger ties than people with like with different beliefs.
I see.
Yeah.
So then were you suggesting to sort of like spread information between these communities, or?
So we never had access to that because it would require live. We would requiring having access to certain social network. But we would idea. So we ran into some literature, and they say that's like actually like if you show somebody the opposite, like a news article with the opposite point of view, it's not actually they actually not gonna if they're actually going to ignore it. So if you believe in A and I show you the opposite of A, you was like, oh, that's fake news, right? So the key is like, you have to like slowly show them it's like similar but like slightly different. You can't give people a totally opposite viewpoint and expect people to listen to it.
I see. That makes sense.
So we never had a chance to like test out the algorithm, but we hope that but we thought that like detecting echo chambers might be the first step in finding a way to break them.
I see. Yeah.
Yeah.
Although maybe people just want to live in their echo chamber. I don't know.
I think Silicon Valley is a massive echo chamber, really.
For sure.
I think we all live in the bubble. And I feel like somehow like this pandemic also makes me realize like to show like how different our bubble is, like how strong it is.
Okay, another just question I wanted to ask you about. So you've recently gone from a like a bigger company to a startup, which is a little bit of a shift. Has there been any surprises there? Has that been like, I guess like how does that feel to go from like big company to startup? Is it a big like cultural shift, or
it's a big different? It's such a big difference. I think, and that's what I wanted, right? I thought that after graduation, I would like to try with different working environments to see which one I would like. So leaving NVIDIA was not a reflection on NVIDIA, just like a reflection on myself because I just wanted to change.
Totally.
Yeah, and my coworkers at NVIDIA have been extremely helpful, and they're really really kind and they're great. So um, it was a bit shock to join a startup. I think it's definitely the first is a workload. It's so much more.
It is
So
so
you know
much more
how,
interesting.
yeah, which is a good thing. So at a big company, you might see people like leaving home at like leaving work at like I don't know 5, 6, and you know at startups you might have people like you might got like PR requests at like midnight on Saturday, right? Which um, which is not a bad thing. I don't know. I think I'm still very ambivalent about on the work life balance discussions. You know, some people say like, oh, you shouldn't like work on the weekend, or like no company should expect the employees to work on a Saturday evening. But the point is like companies might not expect you, but it's like whether you what you expect out of yourself. And I don't want you um I don't want to promote the culture of like you have to work hard, but I do believe that when you're early in the career, there are certain compromises you might have to make, which depends on like what you want out of life. Mm. Anyways, that's a very roundabout way of saying that I work on weekend, but I do work.
It sounds like you're kind of enjoying that experience.
um, I also don't have much in life, so
I guess
um,
right now there's less going on for sure.
so yes, so the big shock is that like yeah, people work on the weekend, and I kind of like it. I'm not sure how much longer I would like it because I also heard that like as soon you like have families, like for you, Lucas, I heard you had a baby recently.
I
Congratulations.
did, yeah, yeah.
Do you still work on the weekend?
I guess like I don't think I have like a very strong point of view. I feel like it's a little bit weird to tell people not to work super hard. Like I worked incredibly hard in my 20s, and I kind of like to imagine that hard work pays off. Um, I think
Did it?
I I feel proud of the stuff that I
Yeah.
did. I think like
You did.
you
You did
know
like you did a great job. I mean, I have done a lot of great things. So
oh, thank you. I mean, I don't know. Like
I'm
I
a
think like I
fan.
don't. If you're lucky enough to have a job where I mean, I think there is a in the best situation, working really hard can be like incredibly fun. Like for me, so often, and I realize like I run I run a company, and you know like maybe I'm coming from a particular point of view, but for me, like working really hard, it can be like a real joy. Like when I actually started my second company, one of the really fun things for me was that it actually made sense for me to like pull an all nighter once in a while, which I hadn't done that in a
Really?
long
Do you
time.
still pull all nighters?
No, I have a baby. It's like, well, I pull a different kind of
That's
all
a
nighter. Let me tell you.
natural all
Yeah,
nighters.
natural
Yeah.
all nighter. It's an unproductive all
Yeah.
nighter. But I also think like I think that the I mean the important thing is like a company's trying to do something, and like figuring out how to do it is the important thing, and like figuring out how to do that over the long term is so like
Yeah.
it needs to be a sustainable pace, because like if you work hard and burn out, that's super counterproductive. But I don't always think that burnout actually comes from like working hard. I think burnout comes more from like working on things that seem pointless, or like
Yeah.
not seeing the success that you
Yeah.
wanted.
I
um
see. Yeah,
so
that
that
makes sense.
yeah, I
So
don't
so I
know.
think if, for me, like seeing people work on the weekend is not a bad thing. It's just like even me, like I also feel motivated to go on the weekend just because I really like what I do, and I have faith in it, and I think I also want to contribute. Like if on a Saturday night I could stay at home and watch some like I don't know some I don't know what's a Bachelor. I don't know watch it, but it's just what people seem to be watching. Or I could like just go on our GitHub and check out some PRs. I don't know, that sounds like a horrible analogy. But yeah, so I think like yeah, I feel motivated. So it's like okay. So anyway, back to the question. So the first thing I noticed is the different workload. And yeah, and I feel okay working on the weekends because I'm so like I can still talk to my coworkers on the weekend, and I like it. And some people are very understanding because people. So I think everyone knows that other people, some people work on the weekend. So people also like gives them more flexibility. Like if you even on the weekday, if you feel like burnt out and like tired, and I want to take a day or two off during the weekend, it's fine as well. So I think I like the understanding of like just making the schedule that work for you. Don't necessarily follow a, a typical like 5 day work week and like work on the weekdays and then take weekend off. I think the second thing is the amount exposure I have to the entire stack. So working in a big company, I'm most focused on very specific product, and I'm shielded away from like one other aspect, as in like um yeah as in like QA or like client, but at startup I get a chance to see everything, and we are sort of building the stack from scratch. So I'm so like exposed to the decisions that we have to make. For example, like what CI/CD tool to use, or like how we should structure a repo. Like, do you want like a mono repo, or do you want like various small repos? So and also like these decisions on like what tools you use, because when you join a big company, usually you have to use the standard tools, and somebody already made the decision for you. But as a startup, you also have a say in choosing the tools, which expose you like various problems as well. So I really like it. Yeah, and also of course also like the size. Like at the big companies, there are a lot of people. I think it's nice at a big company as you have access to a lot of people. But at a startup, you have a small number of college, so you can't randomly message somebody from another team and ask for a coffee, because only you have like just people on the team. Yeah.
Cool, makes sense. All right, so I think we're kind of going over time, and we always end with two
Okay.
questions. I'm really kind of curious to hear your takes on these. So, the first question is that in what is a topic in machine learning that you think people don't talk enough about, or they don't talk? It's an underrated topic that people should talk about more, but they don't.
So I think I have a list of things I usually like throw around. One
right.
of them usually one of them is
Awesome.
a graph. So I love graphs. I used to think that graphs is so underrated, and I think I had a tweet about like a few years ago about it. But I think it has changed. Like I was at New Riffs in December, and I saw so many papers on graphs, and there's a workshop on graphs. That was like the most attended workshop. So I
You're talking about the computer science sense of graph, right?
It's
Or do
like
you mean
graph,
like literally
first
like
like graph network. So
like a
graph
network?
theory. Yeah,
Uh-huh.
yeah. So now we have like they have like several like so a lot of graph like GNN or GCNN and graph convolutional neural network. So I think like there are multiple uses of graphs in deep learning. The first is as so graph is natural representations of like many inputs, right? So we have a data from social network, for example, is a graph, or recommendation systems, and we have like users and items, and it's a bipartite graph. So graph is a natural representation of input, and also like graphs can also like output. So it's like any so a lot of distributions can be represented using graph, like it's pictorial graph. So graphs can be like can represent both input and output, and also like graphs can also have a lot of relationship with convolutions. So they're both local. Um, so they both focus on the local connections. So like graphs like at a point connected to like on its neighboring points, and like convolutions when you have like very local linear transformations. I'm having a very hand wavy explanation right now.
Sure.
I really love graphs, and I'm so happy to see that it's catching on.
Cool.
So I think like other things that underrated is like engineering aspect for machine learning. So I haven't seen much about talking about like integrations for deep learning, or like version control. But I think all of those like people are so like I'm not unique. I feel like what I see other people have already seen, and the company is also catching up on it.
Cool. Good answer. And all right, here's
Hopefully.
the second. Yeah. Well, obviously, I agree. The second question is, in your experience, I'm really curious, I guess, about this one actually. So, in your experience, like taking,
Oh wait,
take,
can I just add?
yeah.
I'm gonna add another thing. So I
Yeah.
still like it's underrated. I think I'm very production oriented, so I think it's like monitoring. So like it's just not experiment tracking for training, but like monitoring in the real world. Like you deploy systems, and how do you monitor it? Like how do you know that when you need to retrain the model? How do you know that the data distribution has shifted? You know, so I haven't seen a lot of monitoring. So I think it's still very underrated.
Yeah, totally. Totally.
Yeah, sorry.
No, and maybe that's the answer
But
to the
trying to sound smart, you know.
I think you're successfully sounding smart. But the second question is, in your experience, taking projects from like training into production
Mhm.
deployed systems, where's the biggest bottleneck? Like, what's the hardest step in that?
One is like clearly right now is when you have very big models, it's really slow to inferencing.
Inference time. Wow, cool.
Yeah, yeah, it's very slow, and it can be very costly.
Uh-huh.
So for example, like if you try to take like GPT-2 to go
Mm-hmm.
into productions, and you just even use spot instances, it also like cost quite a bit for every inferencing, like for every time you make a prediction, like you generate something.
Mm-hmm.
So that's hard. Like if you just like so yes, this is why we haven't seen a lot of GPT-2 in production yet.
Right.
And it's very interesting problem. So like I'm not sure if I can mention the exact company, but some startup told me so they're using GPT-2 in production, and once and they said like if they could reduce the inference time by half, they could be able to break even. So like for
Wow.
example, if they can instead of using the normal precision point, if they can somehow make it works on for some EP16, like half precision point, then it can reduce inference time by half, and therefore when like help the company like stay afloat. And I think it's make a really big difference. Like you just like break even or not in especially in this economy.
Mm-hmm.
Mm.
Yeah, totally. Wow, great answer. Interesting. Um, my final question actually is simple. So, if people want to like learn more about your work, or do you have a Twitter account or a company that you want to
Yes,
tell us about?
I spend too much time on Twitter, and I'm ashamed. But yes, follow me on Twitter.
What's your Twitter
Is
handle?
Chipro as like CHIPRO, and it's not Chipro as like professional. It's more like RO means crazy in Vietnamese. So actually Chipro,
Oh,
yeah.
really? I did not know that.
Yeah,
Awesome.
it's accidental. Yeah.
All right, we should end with that. That was great.
Yeah,
Thanks, Chip.
thanks. Yeah. I also have a blog which I like blog about tech and stuff. But I write long form. Like each my blog post takes me like 2 to 3 months to write. Yeah, so I don't write a lot. But you
But
should
you
check it
write
out
well.
if you have to.
That's great.
Thank you,
Awesome.
thank you. Coming from you
Thank
it
you.
means a lot. Yeah.